Evening. Welcome everybody to Dorkbot number 12 and to a new venue, a very nice, warm, cosy venue here at Tommy's Bar. So glad that so many of you could come. Thank you, Che. More on that later. Okay, so some of you might be here for the first time, so just a quick explanation. Dorkbot is a group of people who are all about interesting applications of creative technology, or people doing strange things with electricity. So that remit is pretty broad. We're not really interested in where you come from, just more interested in ideas and that creative application of technology. So, you could be from an art background or science, engineering. You have designers, musicians, self-taught enthusiasts. Everyone and anyone can present here at Dorkbot, and certainly anyone can turn up. We're interested in people who are doing works in progress, so things which might not be quite finished yet, right through to polished projects that you want to show off and that sort of thing. So what we have for you tonight is 4 presentations by individuals or by groups, and then at the end we have this thing called Open Dorks, which is a sort of, as the name implies, like an open mic kind of thing. So if any of you have come along tonight with a quick thing that you might want to show or get some feedback on, you can do that as well at the end of the night. We've also got, because this one is sort of loosely themed as a games night, we have a game going on in the corner there, and we have something planned for later, which is with this robotic arm that Paul brought along. We're going to play a game of pin the tail on the donkey. Slowly. So we'll start with, we've got 2 presentations. They're going to be about 20 minutes each with questions at the end. Then we'll have a break and then another 2 presentations. So, it'll be about 10, half 10, I think, by the time we finish it. So,
okay, just one thing to add, tonight we have 3 people who are going to talk about games. We have 4 people, on top of the 4 people, 3 people are alumni from the School of Art and Design, this sort of thing. But 1 alumni from illustration, 1 alumni from music technology, and 1 alumni from fine art. We don't do it on purpose, but it looks like we've got a few creative technologists coming from our school.
Yeah.
Yes.
And special thank you to Damon and the Taffy's and Tommy's Bar, sorry, and to the previous guys at Milgie where we used to be. We don't have a budget. We rely on sort of goodwill. We don't pay our presenters. We certainly don't go away each night with money from this all the night. No, it's all voluntary. We are sponsored by Acer. We forgot our dork sign. So anyway, what would you like to introduce?
So let's go Jason. So we have a first speaker tonight, is Jason Bennett, who graduated from music technology 2 years ago, is that right?
Last summer.
Last summer,
This
okay.
year, last year.
And he's going to present his physical audio spectrometer. Yes. Do you want to put it higher up or?
I'll leave it there for now.
Okay.
Yeah, it's fine. Awesome.
Oh, yours.
Right, bear with me, this is a first for me. As Paul said, this was my final project for my end of course last year, music production and technology. But best describe it really. It's obviously a spectrum analyzer but in a physical form, so if you've kind of seen sort of the LED kind of based kind of thing where you put an audio signal in and it shows all the different frequency bands with the LEDs coming up and down, sort of a display that way. I've done a physical representation, so I'll try and keep it simple because it's quite complicated. Took quite a long time to build and develop. Basically there's 10 tubes, so there's 10 bands, so it's representing 10 bands. So it starts only from 20 Hz all the way up to 16 kHz. Got the electronics over there, built the analog circuit, which is basically 10 op-amp circuits. Do some mathematics, tinker around with resistors and capacitors, and then you can define certain band frequencies. That's then sent into a Arduino microcontroller, and then writing some code, taking around with the values coming in and around. That's then sent out to the fans along the bottom. So there's 10 computer fans across the bottom, and they're pulse width modulated fans, which basically means that they can be controlled at certain speeds. The inspiration for the project really was myself. I've kind of DJ'd in a few sort of nightclub venues, worked in bars and that kind of thing. And I thought it'd be nice to kind of maybe get, nice to maybe have a bar with some sort of artistic feature behind the bar or something like that. So we've got an audio signal coming in, and then it kind of displays it. So there's not much really I can say more about it. I mean, I've got a 20-minute slot, but I don't know how I'm going to fill that. You know, best thing to do really is play some music through it. So just kind of show you. I should have brought it on the stage really on reflection, because you guys at the back probably won't be able to see it. But
can you do it still, or is it hard to?
The cables might be a little bit too short to reach. Just go for it anyway. Just have a look. Right, this may not work. I've just put a Bluetooth module into it, so I can do it wirelessly. If not, I'll just have to run it straight on the laptop. So hopefully there won't be any feedback coming out of it. But I'm going to play a bit of adagio strings through it. There we go. Representation to demonstrate with is obviously classical music. It's obviously got a lot of different instruments, a lot of different frequencies going through it. It's not really good with club or house beats really, because obviously we've got a solid thump on the kick drum. You're not really going to display that easily with sort of fans and the inertia from the polystyrene balls going up and down. Consider, whilst I was doing the project, to spray the polystyrene balls with UV paint, which dries white, but when it goes under UV light, it glows a different colour. So when the balls come up to a certain level, they'll glow a different colour, just to give it a different ambience. that's pretty much it. That's good demonstration of what it does. Any questions? Anything?
How much exactly does it cost to build?
Going through all the processes and sort of prototyping, try to keep expenses down. I mean, most expensive part was probably the plexi tubes, because they're not cheap. And I probably got it built for around 450 quid with all the parts, and obviously with the Arduino, the microcontroller and all the electronic bits. But if I was to build it again, I'd probably make it a little bit cheaper than that, but keep the costs down. But yeah, that's pretty much it. Anything else? Yeah.
Yeah. But it's an incredibly mesmerising thing, and it has a lot of potential to do wonderful things, I think, because it's so beautiful. And so you could explore maybe using different materials inside. I was thinking the feathers or something very vulnerable like that would be really extraordinary, or even maybe different things in each of the tubes. But also, have you thought about pitching it to public art projects and things like that?
That's probably the next stage for me, I think, is perhaps getting it out there. So if you guys could possibly put me in touch with people, I'd be very grateful for that. Yeah, but yeah, definitely. I've thought about putting different things in it and messing around, but obviously just at the moment sort of powdered balls were the best option. So.
Was it maybe working on a large orchestra?
Yeah, you possibly could do that. I mean, obviously it's only a prototype, so I'd have to tinker with the coding and that kind of thing, and try to make it quite portable and kind of. The idea basically is obviously you can have it in a sort of a venue, but also if you wanted to, which I do, it's in my flat and it's just it's the size of a fireplace, so it's just against the wall, plug my tunes in and away you go. I'm just sitting there chilling out, so there's potential for so many different kind of things.
You could approach maybe ideas of the Welsh National Opera or the Royal Welsh College of Music and Drama with it as a concept and an idea, because it could really, I mean, on a massive scale as well. Something quite brilliant. And if the Olympics were happening again, they could use this, because actually it's like dancing.
Yeah, that's it. Yeah. That's it. I mean, obviously it's this size, but there's nothing stopping me using bigger, more powerful fans and using different media. It's just obviously the electronics and the brain of it can still control a bigger, larger kind of thing. So yeah.
Make me one for mine.
Yeah, probably can make no problem.
I mentioned you before, didn't I? You could have that in sensory rooms for children with learning difficulties.
Yeah, that's it.
Like that.
Jamie mentioned, like it can also be used in sensory rooms for disadvantaged children. For deaf children, obviously can't hear music. They've got the sensory thing to look at. So it's yeah. That's it. Yeah.
Would it work for noise as well? Rather than just
yeah.
music? So if you, say if you rigged it up and there was a microphone on it, would it pick up
Yeah, you can do.
noises and stuff and reflect the noises in the...
Yeah, it will, yeah. Because obviously it was my final project in university, so obviously I had to step up and display all my knowledge and what I can do and what I've learned. So obviously I went with the analogue electronics, but what I'm thinking of doing now is to just use a microphone and then program I'm going to go a bit tech here, and program the microcontroller using FFT transform, which is just basically it's just all included in the board, so we don't have to have the electronics, which is not so bulky. So you could put a microphone into it and do it that way. So obviously, if anything going on in the room, it'll react to what's going on in the room.
It would be quite fun if you kind of were able to put it on the street and see as kind of traffic went by and people went by talking, kind of.
Yeah, that's it. Yeah. Just reacting to everything.
Sorry, question in two parts. I didn't really fully understand how it was actually reacting to the actual music, even though it looked like a great show. I was also wondering, could it be worked? We had a lecture on a Wednesday evening a month or so back from a lecturer who was doing stuff in randomness.
Yeah.
I was just wondering, could that system work almost in reverse, almost some sort of random system to actually via that to generate the music as such?
Okay, I understand what you're saying. Yeah, I mean, I haven't really thought about that, but that's a good question. Yeah, obviously, there's possibly a way of doing it and creating music with something going on in there. I mean, obviously you have to have like sensors and whatnot. You probably put sensors on the tubes for things going past or breaking the like laser sensors and what have you, and it could probably trigger something. I know there's a guy on my course. He made a light harp. Basically had a laser sender and receiver, and he built it on a wheel. He built it onto a welly. I don't know why he chose a welly to use it, but basically it was plugged into the computer and used the Max MSP. Yeah, Max MSP is a program you can use, and basically he made a harp, but there was no strings. It was just lasers, so you run your fingers through it, and you could use it as a harp. But yeah, you could probably do something like that with balls going up and down, and create music that way on a random.
But how does that actually work at the moment? Is that reacting to the frequencies or something?
Yeah, the electronics board there, the brown one at the bottom. You've got the audio signal going in there, and through the op amps and the electronics in there, it's breaking down the audio signal into certain bands, and that is then sent into the controller. Then I wrote the code for the microcontroller, and then that breaks down all those signals and then tells the fans what to do and what speed to blow the balls up and down. So that's basically what it does. So, yeah.
So if you had a traditional graphic equalizer on top of that the balls would mimic the lights?
It would mimic it to a point, because obviously it's a physical representation, so it's not an accurate instrument to analyse the audio signal. So obviously the light version, or if you're using one on a computer, would be a much better accurate tool to use, but it would be rough. Obviously it's a prototype, I need to kind of fine tune the code, but it's a rough representation. Yeah.
Yeah, I was thinking also if you used fans on top as well,
yeah,
that could give you more responsiveness.
Yeah.
So if you are pumping the stuff down, so if you're like a...
Yeah, that's right. I mean, I could do it now. I mean,
pump down.
If I hold my hand over the top of one of the tubes now, it'll stop blowing.
Yeah.
It'll just drop. Obviously, it's at a holding stage at the moment because there's no music going in. But obviously, when you blow up, you just hold your hand on the top, it drops straight away. So yeah, that's an option.
To get more responsive.
Any other questions?
Yeah, I just want to say that's one of the coolest things I've seen in a very long time.
Oh, thank you.
How did you go about calibrating it? Like, I assume did the fans just work and blow the balls up to the right height, or did you?
Yeah. I haven't got it with me because I haven't got it to be able to display it. But basically, through the prototyping stage, I had a friend of mine. He owns a carpet shop, and I just had one of the cardboard innards out of those with a pair of tights at the bottom, just holding it over the fans, just to see how high the fans could actually blow the balls before I got the plexi tubes. And yeah, it took a lot of calibration. I mean, it was difficult because it was quite a challenge to get it working, to try and get the. Because there's so much information going into that microcontroller. Had to write it's all down to the code basically, and trying to calibrate and capture the right peak numbers. So as the gentleman at the back here was saying, how accurate is it to a one that's very accurate, I basically had one side by side and just went through each individual fan and used one song to kind of map it to basically as a rough thing. But obviously if I was to get a really accurate, then I'd obviously go a lot deeper into the coding and what have you. Yeah.
Did you use any test signals or anything like that?
Yeah, I used the oscilloscopes and that for the electronic side of it, but obviously it is a lot of potluck really, because it's so crazy going on with the fans. It's just obviously it's the timing of them falling back down as well. So we've got to tell the fans to already be spinning, because obviously if they're not spinning, then that little sort of microsecond where it spins up to try and get it to represent it, you've already heard that part of the song, and it's sort of a delay on it, so you've got to kind of calibrate it and work it out that way.
Would it maybe might be if there's a lag or a delay, maybe you want to look at processing the song or the music before it's actually in play, so that you're ready and know if you've got to
Yeah,
fan.
get a head start
Yeah,
on what's
yeah.
coming in. Yeah, that's possible as well. That's another option to look at. Yeah, that's brilliant. Yeah, cool.
Two things. First of all, I don't think you'll have any problem with something for something like this because it's
That's good.
big and deep. It's got so many different applications. The only other place I've seen this is when the water is used to, but I assume it's that completely different technology.
It's a similar thing. I mean, it basically, once you've got the coding down and you've got the audio signal being broken down, you just adapt the hardware. So yeah, you could, instead of fans, you could have like solenoids with jets of water. You know, but obviously then you've got the water coming back down and kind of spoils the illusion then. So obviously it goes up in these.
Application to. I mean, I'm not going to be visual and very stunning what you've done.
Yeah.
Has anybody figured out how it relates to something just like a practical application to?
Not really. I just thought that it would be more of a. Basically, it is more of a visual impact kind of application. Like I said, you know, to actually use it in a practical sense for measuring audio signals, it's not very practical in that sense, but it obviously gives a rough representation. So yeah.
Have you tried putting abstract data through it? Like images, or would you be able to abstract computer files to get...
And put it into an audio kind of signal, is that what you mean?
Yeah, or something that would be represented via the fans.
Yeah, well, that's something to consider. I could do that. I haven't done it, but yeah, that's something, yeah. Anything else?
Have you looked at any other ways to make the balls move? Like, obviously now you're using fans, but have you looked at anything else that can generate movement, like a membrane, or, I don't know, I'm just throwing it out there. I've got no ideas myself.
Yeah, no, that's good. I did consider, the lady here mentioned about water. Obviously, I was thinking of so many different applications, but I think I had such a headache with this when I was putting it together. I think I just thought, get the fans working, but obviously, you know, like I said, you could probably put it to a different application.
So I was thinking if you found another way of helping them move that might be more instantaneous, you
Yeah.
could perhaps then convey something like a drum beat.
Yeah,
If you use like the membrane of the drum,
yeah.
actually the drum, and the balls on top of it, that could be a different.
That's something to consider, yeah. I like that, that's good. Yeah. Any gentleman in white?
I know you mentioned that this device can actually play a lot of like energetic music. What would you think would be able to combat that? Say if you were a producer and wanted a very energetic sound going through this, would you require more equipment, more fans?
That's something to look into. I know Paul mentioned about the. I was thinking of maybe somehow, obviously with Paul mentioned about the fans, is just maybe having like a flap on the top, that if you did want that kind of sharp beat off like a kick drum, then the lower end is that also kicking in or dropping down, so the balls fall, and then it just opens the flap again then to allow them to come back up. But then it's obviously trying to get them to snap and to come back up as well. So yeah, there's a lot of things to sort of implement and consider really. So yeah, that's it. Anyone else? Yeah.
I'm probably showing my generation now, but like that seems to remind me in the reverse sense of Jean-Michel Jarre.
Yeah.
And I just wondered, is there any sort of, I'd imagine you don't want to sort of fall into that kind of territory, but you sort of, you're close, but you're not, you're on the opposite end of the scale as well, sort of thing.
I know what you mean, yeah. Ideally, I would love to see this sort of made even bigger. And I thought about it, but I don't know if it would work, but you don't know until you try. Didn't know this would work until I tried, and I tried hard. But it would be good to possibly kind of throw it out there. Does anyone know about LED throwies? It's just basically LEDs with a battery built onto them. A lot of street artists or taggers, whatever you call them, graffiti artists, that's one. It's like a new age kind of thing where they stick them to high buildings on metal, and they've got like magnetic tape around them. So it's sort of lit up graffiti basically. But they're like little LED throwies, and they're about so big. And they stay on for ages and ages and ages, but I thought it would be great to have sort of 10 of those, or a big tube with a bigger fan that can obviously blow a slightly heavier medium, but having LEDs in there, so it's just all lights sort of bubbling up and down.
You could look at using magnets at both ends of
Yeah.
the tube to move magnets up.
Yeah, that's a possibility. Yeah. So yeah, it's an endless journey with it really. There's a lot of applications, different things you can use, bigger fans, different mediums inside the tubes. So yeah, that's it really. Any other questions? No, all good. I think that's me. I think that's everything.